Catapults have been in use since early days, when they were used for hurling stones at battlements. In about 1909, Wright's earlier flights were made from a form of land catapult. It was in 1911 that the possibilities of the catapult for launching aircraft from a restricted space in a battleship or cruiser were considered. This was by the United States naval authorities. During the years 1911 to 14, they developed 3 designs of catapult in the form of a ram operated by compressed air. Experiments were carried out by launching aircraft from a barge. Catapults were then installed in warships, but were insufficiently developed for use at sea during the War of 1914 to 18. In 1916, this country took steps to develop catapults, but it was not until 1922 that any great advance was made by either country. There are now several types of catapult installed in most cruisers and battleships, built or building in our Navy, each new type being an improvement on the last. Catapults are operated by a system of wires and pulleys in conjunction with a ram operated by compressed air or cordite. Since 1928, cordite only has been used, the charge being inserted in a breech at the end of the cylinder in which the ram operates. The aircraft is launched from a carriage known as the catapult trolley superstructure. It is supported by 4 catapult spools, and the carriage is driven along the catapult track at a maximum acceleration of 2 3/4 G. Here we see a light shot fired by a light charge which is employed to test the mechanism without an aircraft. Here's the same shot in slow motion. In cruisers, the legs begin to collapse at the end of the acceleration about 3/4 of a way along the track. In later battleships, the rear legs are fixed. The early turntable and turret type catapults in use today have been replaced by deck types. Deck types may be used on either beam of the ship, and in cruisers are provided with extensions to give the necessary launching run. Deck types also have hangars for the stowage of 2 additional folded aircraft. In earlier deck types, the aircraft in the hangars are stowed on loading bogies, which are traversed by power to transfer the aircraft from the bogie to the catapult trolley superstructure. It should be noted that the loading bogie is fitted with amphibian loading gear legs and rigid nose trimming gear, which is being introduced to simplify the loading operation in rough weather. The rigid nose trimming gear can be transferred for loading aircraft direct to the catapult. It replaces an older type of flexible nose chain. In later deck types, which have been designed for the King George V and Fiji class ships, the aircraft in the 2 hangars are stowed on the catapult trolley superstructure from which they are launched. The trolley can be transferred to the catapult track at a turntable, where it is attached to the catapult wires for the launch. This shows the method of attachment in a cruiser with a D4H type catapult. Standardized aircraft spaces in each ship include an office. Here is a ready-use store and workshop for toolkits, crash gear and small equipment. Spare fabric parts are stowed in marked and padded racks in the hangars of cruisers, or in a separate store in battleships. The spare engine is stowed in a case supported on a low trolley. Items such as main planes, which are too large to put in a store, are stowed in racks in each hangar unless boxed stowage is available. This is a typical darkroom for which the observer is normally responsible, and in which there is provided a sink, vertical enlarger, and the necessary lockers. A drying drum is also provided either in or just outside the darkroom. All personnel who work about the aircraft should be trained in the operation of the fire extinguishing appliances. Sprays are fitted in the roof of each hangar. 2 control positions are provided for these sprays, one close to the control for the hangar shutters, and the other near the alternative access door to the hangar. A 2-gallon fire extinguisher is fitted close to each access door. 2 twin foam generators are provided on or adjacent to the catapult deck, one on each side of the catapult. Screens are fitted round these generators, upon which the hoses must always be stowed in the ready position. A fueling and defueling system is provided in each hangar, from which flexible pipes are brought to the aircraft fuel tanks. Aircraft can also be fueled or defueled on the catapult. This shows the small aircraft Zwicky hand pump being used. A larger ship's Zwicky hand pump will further increase speed of defueling. The catapult communications from the compass platform and from each bitch worker are brought to one central control position on the catapult deck. We will now demonstrate the operation of launching and recovering aircraft from the stowed position on a loading bogey in the catapult training and experimental ship HMS Pegasus, which is fitted with a D1H type catapult. It must be imagined that the loading bogey is stowed in a hangar, as it would be in the Southampton and Cumberland class cruisers, fitted with this type of catapult. Before launching the aircraft, the seaplane launching party, which consists of the catapult's crew, bogey's crew, and aircraft ratings, is closed up and dispersed to their stations. If required to carry out bombing, the aircraft would now be armed by aircraft ratings. Each bomb is supplied by a gunner's or supply party using a special bomb loading stretcher. The bomb is then raised to the rack by a loading winch and is engaged in the rack by the armourer. The aircraft should by now have been manned by the crew and a fitter with the handle ready to start the engine when required. Aircraft ratings are stationed with lines rove ready to spread the wings as soon as the aircraft is clear of the hangar. The pilot verifies that all loose gear in the aircraft has been secured. The directing officer now directs the aircraft to be loaded on, and the catapult officer orders the control worker or rating detail to traverse the bogey clear of the hangar. At the same time, the aircraft is trimmed on the bogey to the loading trim by the leading rating of the bogey's crew, while the jack workers pump up the jacks. The directing officer orders the aircraft ratings to spread the wings. During these preliminaries, the ERA, number one of the catapult's crew, has been preparing the catapult. He sees maneuvering levers central and puts power on the pump. He sees the track and ropes are clear. Extension locking bolts and trolley securing pin are put to out. He sees that extensions are clear for extending and ram for moving. Superstructure oleo legs are topped up. Liquid level in the catapult receivers is checked. Crosshead detents are engaged for the direction of launch. The catapult officer receives reports. The pump is started, after which the control worker is not to leave the control position. The control worker extends the catapult. These extensions are not fitted in battleships, which have sufficient beam for a fixed track. The trolley is traversed to the firing position to enable the firing gear to be tested. Meanwhile, the directing officer verifies from the pilot that the aircraft weight is between the maximum and minimum permissible for catapulting, taking care that the estimated catapult speed does not exceed the maximum launching speed of the catapult, as laid down in the drill. He has also to ensure, in collaboration with the captain, that the aircraft is launched within the limiting wind conditions. The bridge worker has provided the necessary catapult charge with one spare charge and shown them to the directing officer, who ensures that they are the correct zone charge for the weight of aircraft to be launched. He now tests the firing mechanism before the first launch. He closes the bridge and tests the striker. He recocks and reports to the control worker. The control worker puts over his launching lever. The bridge worker reports if the lock has fired correctly. The control worker returns his lever to the ready position and reports that the firing mechanism is correct. The catapult officer now directs the trolley to be traversed to its loading stop, where it is locked in position by another stop. It is turned 90 degrees to face the loading bogey. The bogey is traversed so that the aircraft front spools enter the jaws of the trolley superstructure and the front jaw locking bolts are returned to the up position. This completes the loading operation. The leading hand of the bogey's crew is trimming the aircraft to engage the rear catapult spools. He can then, by order of the catapult officer, disconnect the nose trimming gear. The aircraft wheels are pumped up by the pilot. The bogey's crew remove top half brasses which secure the aircraft in the bogey legs. The jacks are eased until the weight of the aircraft is taken by the catapult trolley superstructure. The bogey legs are collapsed and the catapult officer orders the bogey to be traversed clear of the aircraft. The retractable spool fittings which locate in the loading legs are retracted by aircraft ratings. In rough weather, hauling back cables should now be on to secure the aircraft in the trolley. Aircraft ratings and catapult's crew turn the trolley to the required direction for launching. When the trolley has been relocked by the ERA and loading stops removed, the catapult officer directs the aircraft crew to start and warm up the engine. The catapult officer now checks the rope tension on the catapult wires, which may differ between maneuvering and launching the trolley. He then tells the pilot that he may run up his engine to test it. While the engine is running up, he checks the clearances between the rear hooks and rear spools. He then receives the pilot's affirmative signal and reports to the directing officer that the catapulted aircraft are cleared away. This is transmitted to the captain by telephone and transmitter. Meanwhile, two signalmen have closed up for repeating flag signals on the bridge and on the catapult platform. The red flag indicates that the catapult is not ready for firing. Two ratings are also stationed on the bridge and at the control position to operate order transmitters and telephones. The aeroplane flag is at the dip to indicate that an aircraft will shortly be launched. The captain receives the cleared away report, and when ready, he orders standby to launch. This order is passed to the directing officer by telephone and transmitter. The directing officer now directs aircraft ratings to remove the hauling back cables, which, in high winds, are left secured until the standby order is received. He repeats the order standby to the catapult officer. This order is passed to the bridge worker by telegraph. The bridge worker proceeds to make up the catapult charge. He inserts the primer by means of a special key supplied for the purpose. He fits a protecting clip. He removes the charge from its cardboard container and inserts it in the cartridge case. He ties a saloon braid securing tape securely across the mouth of the case, which prevents the charge surging forward after being inserted in the bridge. Sentries detailed from the seaplane launching party are then posted to prevent anyone crossing the track. The catapult officer, on receiving the order to stand by, directs the catapult's crew to prepare the trolley. The rear leg firing pins are taken out. The ERA engages the superstructure trip gear. The safety clips are removed from the front leg. Once the trip gear is engaged, the platform must be cleared. The control worker, at the order of the catapult officer, maneuvers the trolley to the firing position, and the main cylinder is vented at this stage. As soon as the ram is in the firing position, the bridge worker drains the explosion unit chamber and main cylinder. He should then see that the release valve is closed. The catapult officer satisfies himself that the catapult is ready for firing, and then reports to the directing officer. He uses a blue hand flag owing to the noise of the aircraft engine. The directing officer informs the captain by telephone and transmitter that he is ready to launch. The signalmen lower their red flags. The captain sees that the course of the ship is suitable to obtain the necessary wind conditions and orders launch when ready. The signalmen raise blue flags. The aeroplane flag is hoisted close up. The order is passed to the catapult by telephone and transmitter. The directing officer ensures that the blue flag is still displayed, raises his blue flag above his head, and moves his telegraph to load. The bridge worker opens the bridge and inserts the safety U-piece. He loads carefully with the base of the case held down. He moves the breech slightly to hold the cartridge case, removes the protecting clip, then closes the breech. He sees the striker cocked, removes the U-piece, and reports loaded and ready. The directing officer circles his flag. The pilot sees that his crew are ready and runs up his engine. He raises his hand above his head in view of the directing officer and cuts it down. The directing officer waits a pause and drops his flag. The control worker puts over his launching lever smartly, and away she goes. He drops slightly. It's a crosswind. If the ship were rolling, the launch would be started on an upward roll. The launching lever has been held over until the launch is complete. The breech worker is directed to open the release valve. The catapult's crew prepare the trolley for whatever further operations are required. If the aircraft were being launched at sea, a seaboat would be manned with an aircraft rating, sick berth rating, and crash gear in it. The crash box contains axes, saws, and tools for breaking into aircraft hulls, etc., a modified salvos breathing apparatus in a special box, fire extinguishers, and flame-proof clothing are also provided. In harbour, the crash boat is manned at the boom, or in the vicinity of the area while aircraft are being launched or landed. Prior to a catapult launch, the crane would be rigged by the torpedo party in readiness to recover aircraft at short notice. We will now show the operation of recovering the aircraft, to include the full equipment of steadying gear recommended for rough weather conditions. The captain decides that the aircraft will be hoisted on the starboard side, and the ship's course is set with the wind about 60 degrees on the starboard bow. The aircraft is informed by signal that the ship will damp down the rough water in its wake by making what is known as a slick. The aeroplane flag with flag B inferior is hoisted at the dip at the starboard yard arm. Meanwhile, the starboard lower boom has been rigged for recovery by the towed method. The seaplane recovery party close up. This party consists of the catapult's crew, the bogey's crew, and aircraft ratings, as in the seaplane launching party, and in addition, a handling party detailed from the watch on deck. Under rough conditions, it will be necessary for the handling party to consist of about 7 or 10 ratings detailed from those most likely to be available under action conditions. The directing officer sees that the torpedo party carry out a test deck mating of the Thomas grab to ensure that the wave compensator barrel is functioning correctly. He then ensures that the quick release coupling is set correctly with the pin in. The particular ratings detailed from the aircraft and handling parties man 2 bearing out spars and provide the necessary steadying lines and steadying tackles. Steadying lines are made up of 1.5-inch sisal, or in rough weather, a stronger set of 2-inch rope. 3 lines are hooked on by the special hooks provided to a ring seized to the strop of the quick-release coupling. A hand detailed from the handling party reeves the tricing line of the 5-inch grass recovery hawser through a block at the crane jib head. If the boom is far ahead of the crane, it may be necessary to reeve 2 of these tricing lines to keep the hawser clear of the water. The crane is then trained over the ship's side and the jib lowered to the correct radius for aircraft recovery. The quick-release coupling is now lowered to the correct height for the hooker-on to reach it. The quick-release coupling is supported by tricing wires from a winch in the form of a fluid flywheel. The crane operator adjusts this winch so that the quick-release coupling is stationary and balanced. The hooker-on can now haul down the coupling and overcome the winch with very little effort. When ready, the officer concerned reports to the captain that the boom is ready for recovery. The directing officer reports that the crane, catapult, and seaplane recovery party are ready for recovery. The captain can now recover the aircraft when he wishes. He orders the amount of helm which has been found in practice to give the best slick for his ship to swing the bows of the ship through the direction from which the wind is blowing. The signal close-up indicates to the aircraft the wheel being put over. This is the executive signal to the pilot that he may select the best moment for landing in the calm patch made by the slick. The signal is hauled down when the ship's head passes through the direction of the wind. The aircraft is approaching the smooth patch of water, in this case in comparatively calm seas. The pilot must be practiced in this approach so as to cause the least possible delay in recovery. He's coming in, flying slowly and using his engine. He flies low over the water until he selects the right spot in the slick for his final tail-down alighting. He taxis up to the tow while one of his crew prepares to hook onto the crane. In very rough weather, when the aircraft cannot taxi fast enough or caravans are running, the ship will have to complete a 360-degree turn after making a slick to come alongside the aircraft from astern. As soon as the aircraft alights, the speed of the ship is adjusted to allow the pilot to taxi up to the tow at a reasonable speed without possibility of overshooting owing to the tractive force of his engine. The course of the ship is steadied with the wind about 30 degrees on the port bow to give sufficient lee without causing indraft. The hooker-on is secured by a safety belt and is ready on the center section. The observer or passenger stands by to hook on the aircraft towing pennant with a spring hook on the towing hawser. If it were very rough, he would use the side window. The pilot throttles back slowly after hooking on, and he must continue to steer and control his aircraft until it is hoisted clear of the water. The tow should be adjusted so that the aircraft tows under the crane. The hooker-on hauls down on the coupling, he hooks on and holds up his hand. A pull is now put on the tricing wires to hold the aircraft under the crane, and the hooker-on removes the pin of the coupling in case it is necessary to slip at short notice. The directing officer orders mate and hoist. The crane operator now puts the tricing winch controller full over, which exerts more pull on the tricing wires. This mates the grab, which also puts tension on a spring in the purchased compensator barrel. After the mate, the crane operator must immediately clutch in the pawls on this compensator barrel. This prevents the aircraft dropping back into a trough of a wave, while the spring takes up slack in the purchase if the aircraft rises on a wave. The pilot stops his engine and the hooker-on replaces the pin. He then unhooks the 3 steadying lines and passes them to the pilot and observer, who hook them onto the aircraft handling lines. At a sign from the directing officer, the pilot in the cockpit slips the tow from a release in the bow of the aircraft. As soon as the aircraft is under control of the wing-tip steadying lines, the hoisting is continued. The aircraft should be steadied with the nose towards the crane. The handling party take rendering turns over cleats in appropriate positions. They must keep the aircraft steady, nose to crane. If necessary, the second tail handling line may now be released by the pilot for further steadying. As soon as the aircraft is over the deck, the crew release 2 wire martingales from which a steadying tackle is bowsed down to a jackstay, led across the deck to the loading on position. The crane is trained and the friction on the shackle gives considerable steadying effect. Aircraft ratings release and extend the aircraft retractable spool fitting and fit stirrup links onto them. Detailed ratings of the handling party hook tackles onto the stirrup links to take over control of the aircraft. The tackle under the hull may now be unhooked and the loading legs erected for loading aircraft. If amphibian loading gear was not in use, the catapult trolley would be traversed into the loading on position at this juncture. The aircraft spools can be finally guided into the loading legs by hauling down on the positioning tackles, the pennants of which are passed over hooks on the stirrup links. The nose trimming gear is attached as soon as the spools are steadied in the loading legs. The directing officer lowers purchase at creep speed until the legs have the weight of the aircraft. Top bearing caps are then put on and secured. The nose gear is trimmed to a marked position. The purchase can then be unhooked. The trolley is now brought onto the stops at the base of the loading gear, the last few inches slowly to avoid undue shock. The front jaws of the trolley automatically take the catapult spools. The aircraft is trimmed to engage the rear spools. The top bearing caps are removed and the weight taken off the lower bearings. The legs are then collapsed and the loading gear removed. Meanwhile, steadying gear has been stowed away by the aircraft ratings and handling party. If the aircraft is to be stowed, the standard securing gear is put on by the aircraft ratings. It should be noted how the hauling back cables, which are the most important part of securing gear, are attached to the aircraft spool fitting and to the trolley base. This has shown the operation of steadying aircraft in rough weather. Some of the gear used could be dispensed with as considered desirable in calm weather. This is also dependent upon the wingtip clearances in the loading on space. For night operations, an exactly similar procedure is carried out. Shaded torches are used for passing all the necessary signals. The most important ship's fittings in use are painted white. Cranes should also be marked to facilitate luffing and training to the required loading position. Now here are some reminders for the pilots. Remember those wheels. This actually shows a Nimrod ship plane during a special trial. But see what happens if you don't have a recognized drill amongst your crew for checking the position of the wheels before you land. And another one. See that your passenger, as well as the gear, is correctly strapped in before you are launched. This episode happened some years ago. The passenger hung on and was only bruised, but think what might have happened. These are some correct landings in rougher weather. Notice the technique. He brings the aircraft in slowly and flies it onto the water with the tail down and using plenty of engine. Then, using the minimum of power necessary, he flies a few feet above the tops of the waves until a spot for landing is selected. He then throttles right back, holds off as long as possible, and makes a fully stalled landing from about 6 feet. He's prepared to give a good burst of engine to ease the aircraft down if it bounces. Notice that the tail of the aircraft touches the water first, and the landing is as smooth as could be expected. Amphibian aircraft can land safely in rougher seas than float plane types.